Again, just like to welcome the panel and welcome you all today to our discussion, which is speeding solutions for cancer care with open science. As Mark said, my name is Dr. Roland Dilling. I'm the Director and Chief Medical Officer of AWS Public Sector Health International. I'm actually also an academic interventional radiologist with an interest in cancer intervention. As Mark said, the topic of today's panel is around Cancer Moonshot 2, how the federal agencies are adapting to this, and also the non-federal agencies. Last year, President Biden reignited the Cancer Moonshot with the goal of reducing the death rate from cancer by at least 50% over the next 25 years. And that's very important, as we know from a paper that was published last year by CDC, that the expected number of cancers diagnosed in the US is going to increase 49% to 2050. And that's due to a combination of an aging population and also population growth in and of itself. So what's open science? Because that's the other part of this panel. So open science, well, according to the federal government's open science portal, open science is the principle and practice of making research products and processes available to all while respecting diverse cultures, maintaining security and privacy, and fostering collaborations, reproducibility, and equity. What that boils down to are three things: open access, open data, and open source. And we can dive into those a little bit more during the panel. In fact, 2023 has become the year of open science by the US federal government. And all of those things align to the AWS healthcare mission to enable access and delivery of person-centered care to improve outcomes at a lower cost by accelerating the digitization and utilization of healthcare data. So with that framing, I'd be delighted to turn to the panel now and really understand what the administration and the agencies are now doing. So Annabella, you were part of the original Cancer Moonshot under then Vice President Biden, where you served as the Director of Patient Engagement. You then moved to an AI company, and you've now returned to the administration as, within the Cancer Moonshot. It'd be really interesting to understand in your new role as Assistant Director of Public Engagement, how you're engaging with federal agencies, non-federal agencies, and commercial entities.
Absolutely. First, if you'll indulge me, I would love to ask the audience a question, just so I can
Of course,
I think
that's ideal. I mean, who knows how many in the audience actually know what the Cancer Moonshot is?
That's what I was going to ask. I would love to see, just by show of hands, one just shot up. I would love to see by show of hands.
One person so far.
One person. Who has heard of the Cancer Moonshot?
All right.
Okay.
Okay. Of course, the lights are so bright. I don't know that that was a great read on my end. But yes, thank you so much for letting me know that, because I was telling my panelists and Roland earlier that we need to be as strong as the public's ability to talk about our work. So let me answer your question by first saying what our work is. The reignited Cancer Moonshot is the President and First Lady Biden's commitment to end cancer as we know it. It was reignited in February of 2022 with actually two bold new goals. Roland definitely got one of them, the very quantitative goal, which is to reduce the death rate from cancer by at least 50% in the next 25 years for all of the reasons that you mentioned. But the second, less quantifiable, more qualifiable goal of improving the experience of patients and families living with and surviving cancer. So those are our two audacious goals. The way that we achieve them is that in tandem with the reignited Cancer Moonshot, the President stood up a cancer cabinet. The cancer cabinet consists of about 20 federal agencies and sub-agencies, including my colleague to the left, who are responsible for setting our priorities and then new actions and collaborations to achieve meaningful progress against these priorities. So just to walk through those 5 priority areas, the first is to close the screening gap. We know that 10 million Americans missed their recommended screenings because of the disruption that COVID caused on the healthcare system. How do we jumpstart those screenings again and also ensure that screening technology and screening science is more equitably distributed across the public? And hopefully I get the chance to speak more about that later. Understanding and addressing environmental and toxic exposures. The research is showing that exposures to certain environmental conditions is causing an increased risk of cancer. The onus is on the government to understand this space better so that we can both regulate and eliminate exposures that can cause cancer, what are my priorities? Preventing preventable cancers. Today we have more tools than ever to prevent cancer, and I'm talking about the HPV vaccine, which can prevent cervical head and neck cancers. I'm talking about the hepatitis C antiviral, which can prevent liver cancer. I'm talking about colonoscopies, which can catch precancerous growths and prevent colorectal cancer. We also have a better understanding of the science behind modifiable risk factors like diet and smoking. So we really are well positioned to, if not wholly eliminate, dramatically reduce the incidence of certain cancers. Number 4, to deliver innovation through the pipeline to patients and communities. For certain cancers, we have to develop and deploy new ways of detecting, treating cancers, because there are certain cancers that are going the wrong direction. I'm talking about ovarian and endometrial cancers where the incidence has jumped, and we will need new treatments and technologies to improve survivorship in these cancers. I would also include rare and pediatric cancers as well. And then last but not least, a priority that the President and First Lady will never, ever not have, which is to support patients and families. And in this bucket, I just think of every action that makes cancer patients feel less alone and addresses gaps in our healthcare system so that cancer is not such a catastrophic diagnosis. So that's our work in a nutshell. Just to your question, which is how we engage, that's how we engage federal partners. How we engage non-federal partners. Well, the President and the First Lady have said time and time again that we cannot achieve the audacious goals of the Cancer Moonshot without everyone doing their part. So my role as driving public engagement is to look at folks like yourselves, the private sector, academic, foundations, nonprofits, the entire non-federal ecosystem, reflect our goals and priorities to them and ask them how they can step up. And I think we're very fortunate that AWS and Allison will say more about this, heard that call and stepped up with a commitment as part of the Cancer Moonshot, but I'll let them say more.
I think they're really interesting goals and very, as you said, audacious goals. And I think everyone here will either have some personal contact with cancer themselves or a loved one. So I think everyone here can agree that these are really important priorities. Now, again, we're very lucky to have on the panel representatives of all those groups you've just spoken about. So part of what you're describing relies on massive amounts of data. And it relies on federal agencies to come together and to work in a coordinated manner. And also sharing that data more broadly across all of the stakeholders. So Jeff, in your role, and you're representing federal agencies, you're not only responsible for the IT infrastructure of the National Cancer Institute and the confidentiality and the integrity of that data, but also prompt data sharing and access at the point of need. And I can see there's some tension between those two things. So how do you manage that tension when we talk to all the patient advocacy groups and they're demanding early access to patient data? How are you evolving to balance those needs?
Well, I really wanted to thank Annabelle for that really, good, detailed business case, because I know all of you in this space are, that's a great place to start your work, right? What are we actually trying to accomplish? And so if we were to look at our space, to get maybe the long-winded answer to your question, if we were to look at our space, people have been doing this work for many decades. And so we have a lot of procedures, a lot of way to standardize data collection. But if you were to look, when the Cancer Moonshot was launched, part of the reason it was launched is that there was a change. We all of a sudden had so much more digitization in this space. And we had kind of really an analog working model. And so if we even think about your question about how do we do both? How do we both protect the data, make sure it's correct, and then make it available to everyone? And so, well, ideally, we use technology to do that. And so the Cancer Moonshot came at a time that it was driven by the digitization, but it was also driven by the realization that we're really not doing things the right way. We're not really taking advantage of all the technology that's available to us. And one of the main goals is to say we should use cloud technologies to bring everyone together. So if we look at it, part of the question is really how do we break things down? And rather than think about things as systems, we generally like to think about them as data, because we really have a lot more data than we can really manage very well. And so, of course, that's changing all the time because there's new technologies generating data. So a big part of what we're really trying to do is to make sure that we build the infrastructure in such a way that it is kind of self-contained in terms of its ability to protect the data. And so, and I would say that's really not very difficult to do. Also not really difficult to do is to start to put these systems together so that people can utilize the data. I'd say the two main things that we're really struggling with and doing a lot of work on is making sure that when the data comes in, it is actually, you're actually able to unite it together. So one of the issues we have is related to patient privacy. So you all are going to have this in your space, right? You're going to have issues where you can say, well, if we could only get rid of this one thing. Well, we have patient privacy, so when someone gets cancer, you have their information, you have a lot of detailed information about them, but do you have that information in 5 years? Do you know their status in 5 years? Well, generally, unless they're enrolled in a clinical trial and you're longitudinally following them, you don't. And so, so those are some of the things to say, well, could we do that? Should we do that? And there's a bunch of work that I know Allison's going to talk about a little bit that talks say, yes, we can do that, and does it really pay off? So I think we're generally using, I would say, standard basic cybersecurity technologies to protect the data. We have some very, very intricate patient privacy models where we are able to keep information protected where we know who the person is, but we don't have access to that, nor do any of the researchers have access to that, so we can longitudinally continue to connect the data as we get more information about that person. This patient privacy work, so we do a lot of complicated work in that space. And then I know we're going to talk about this, but the biggest thing we have to really do is educate the people who need to use the data. So it used to be just researchers did it. Now we need clinicians to do it more. And then, and like we talked about, we really want to have people do it. We want to have people say, I got this report from my doctor and I really don't know what it means. I've never heard of this before. What do I do? Who should I tell? Who should I go see? Who are the experts? All that, a lot of that stuff is available, but we really need to be able to train people to learn how to consume that information. And of course, make it easier to consume.
Yeah, I think that workforce education piece is actually very important as well. So we actually have a head of global healthcare workforce education working with research organizations and hospital networks around the world, specifically to upskill so that you don't need advanced machine learning experts or data scientists or IT professionals can really work alongside clinicians and care providers to really access data at the point of need. So I think that's an incredibly important thrust in that direction. Now, of course, in terms of actually a use case of what's going on with the Cancer Moonshot 2 and how we're leveraging the infrastructure, an example of that is the Children's Brain Tumor Network, which AWS is very happy to support. And we also support the Pediatric Brain Tumor Atlas and the Gabriella Miller Kids First Data Resource Center, which is utilizing the AWS cloud to store and securely share that data. So Allison, from the CHOP point of view, and moving on to the non-federal partners, the federal partners and now the non-federal partners, what's the role of CHOP and how are you leveraging this technology as part of the Children's Brain Tumor Network?
Yeah, I mean, it's been great to kind of be set up to talk a little bit more about this from Annabelle and Jeff and Roland. And I think it's been really interesting. I've been at CHOP for 6 years now, really seeing this kind of new wave of technical infrastructure. And I think as part of that, I'm in a center, the Center for Data-Driven Discovery and Biomedicine, or D3B, and part of our mandate is how do we connect the clinical side and the research side in more real-time ways through data technology. And one of our forefront initiatives is the Children's Brain Tumor Network. And we're really rooted in trying to understand pediatric brain tumors. And it's really been kind of the leading edge of what we've been trying to do, because both it's the leading cause of death by disease in children now. There have not been new drugs developed for the last decade. And there's a real timeliness component to it. Your kid gets diagnosed with a brain tumor. Depending on the different ones, you can be talking 9 months. What can you do in 9 months for your kid?
I was actually going to say, maybe, again, for the audience who may not know what the Children's Brain Tumor Network is,
Yeah,
maybe
so
just
I was about to just dive into that.
Go into it, yeah.
So as part of that, that's where CBTN came from. No one institution can do this. No, single person. And so the Children's Brain Tumor Network is now 32 different sites and expanding around internationally. And actually, it was rooted originally in the tissue, the specimens, surgeons going in and doing brain tumor surgery. We biobank the samples at CHOP, but suddenly became, we can do genomic characterization. We can start looking at the sequence of this data. We can start pairing that with the clinical data, and it became more. So originally it was an acronym that was really hard to say, CBTTC. As soon as I learned how to say it, we transitioned to CBTN, the tumor network, because it's not just about the specimens. It's about the data, it's about the platforms, it's about the infrastructure to do this. And to your point, there's very broad data sharing agreements that happen. Each one of the sites contributes it, and they're also promising to make that data available pre-publication without embargo. And I think what's really been interesting is to create the tech to meet that mandate has been just as hard to get people to agree to it. So in our space, everyone who's involved really wants to see that data out there. Anyone who wants to do analysis on pediatric brain tumors, who wants to understand how they work, who wants to push forward to cures are more than welcome. Look at the data. But your point about a lot of times, especially as new sites or other things come on, you're using legacy systems, you're using kind of different ways of doing this. And so really has been pushing, and we have also brought together different partners here. So we have, as part of our center, we also run the Kids First Data Resource Center. So this is an NIH initiative to do that across pediatric diseases, structural birth defects, pediatric cancer. But if you look at the CBTN, where it's really starting to connect that research to the clinic, how do you do the different imaging modalities, the different genomic modalities? How do you have real-time clinical data? You're really starting to push on these platforms of how do we get the data out? And so I think the partnerships with some of our commercial partners, Cavatica is one of our cloud platforms that Seven Bridges, now Vocera, runs on AWS. Our core infrastructure runs on AWS. But at the end of the day, it's not about any one of those particular solutions. It's really about the mission, the mandate, how do we get the real-time data out? How do we share it in the way that everyone expects it to be shared? And how do we make sure that it's being empowered by all the different people who can provide input, towards discovering cures?
I think that's really interesting. I think the real-world evidence is a hot topic at the moment, and how to make these data repositories not just passive repositories of historic data which can then be looked at by researchers, but to actually making them actionable in real time. Have you found that at CHOP? Are you actually able now to derive insights from the data that's being gathered in real time? Is that something that's there, or is that something that's still potential?
So I think we're starting to see hints of it, and it's in the rarer, and it's in the the ones that have this kind of time component of it, that it really need to do something as soon as possible. And I'll say it's not just at CHOP, CBTN, we have very strong partnerships. Our first 3 pilot EHR setup is with Seattle Children's and UCSF. And so we're not just doing it alone at CHOP. We have these kind of network partnerships. And so what happens, and we have starting to have hits of the CBTN has a partnership with a clinical trial network called PNOC, where we're running clinical trials where kid comes in, we're doing real-time sequencing, real-time analysis, and there was a recent case where it came back and the known actionable things that you could do, there was nothing. And so that moved into the research space. We did research-grade analytics, because at that point, what else are you going to do? And the research side started saying, maybe if you combine these different drugs, that might help in this. And then you get together a molecular tumor board, clinicians come together and they say, for this case, we are going to go ahead and recommend that based on the research analytics that were done. And that's what we're starting to see, that divide of the data, the same genomics data that was generated clinically can go into the research space. Research analytics in cases where there's not a clear path on the clinical side can then inform clinicians who can use their own knowledge to make the decisions on how best to treat the patients.
And I think that's really encouraging, where data can be taken out of the electronic medical record, which is kind of the clinical repository for patients, and then actually used and aggregated, and then used for research purposes as well. I think that crossover between the clinical and the research is really important. But obviously this then goes to federating data and how you're able to aggregate data from different centers that maybe have different rules and then bring them together and access them in secure ways. This really goes back to Jeff about federated data platforms and how are you able to manage those federated data? And again, AWS is doing a lot of work around these kind of projects. We're developing specific services such as AWS Clean Rooms and Amazon Data Zone. Are you leveraging the technology to enable this?
I mean, I think we're consuming the technology that enables it. I think when you asked Allison how all this happens, I was going to say lots and lots of meetings, and really it's because a lot of these things haven't been done before. So we're trying to consume all the modern technologies that in this case, like our AWS partners can provide us. We have to then. So really, what is federated data? It's basically data that's kept independent of each other. So if you're going to use it, you're obviously using it as, joining it together. So you need to have those connectors. So if you were to look at it from a data perspective, you need either good patient identifiers, you need good disease coding, and then you need some kind of understanding of how all that technology work was done, whether it's like Allison mentioned the sequencing, you also have a lot of imaging work that's done on the tumors. And so those can be at different places because we know those things happen in different places. So it's really about in our case, the Cancer Research Data Commons, where this is not like the real-time data, but it's data that we have. It's really trying to put a layer on top of that, a user interface layer where you can go down and you can ask certain questions and you don't have to manually assemble all that data together. So that's a big focus that we're working on right now, which is basically creating user interfaces so in the cloud where people can ask certain questions and then the bots, or however you want to think about it, the code, the systems will be connected together with enough authorization set up so that the questions can be answered. So
I guess there's an element here about, oh, sorry.
No, forgive me. I wanted to jump in on, because this isn't a room of clinicians, I wanted to just piggyback on a point that Allison made just in case for the benefit of this group, which is that there's another potential use case for that data in the RWE that you were talking about. And that is that Allison is mentioning diseases that have a very small N. We did a brain cancers forum at the White House a few weeks ago. One of the cancers of focus was DIPG, which is a highly fatal pediatric brain cancer, and there are only about 300 diagnoses of this a year. So the data that we're talking about could also be used, best case scenario, as a control arm when we don't want to turn to a family and expect that they'll be comfortable with a placebo, especially given the timeframes that you talked about. So I just wanted to highlight that, because in some ways, if data becomes a control arm, especially in these rare diseases, I mean, we could see tremendous benefit.
That's really interesting. And obviously, CHOP's been ahead of the game when it comes to genomic data sharing and in an open science perspective. You've been doing it for some time, but obviously a lot of the other institutions haven't. So how do you see that transition? How are other institutions following your lead, or are they lagging behind?
So kind of connecting all those, I think some of what we've been able to do, NCI has really led the way in a lot of the policies that we were able to build on top of, when you are able to go and say, NCI, is pushing for data sharing, and they're starting to think of tools of how do you link patients longitudinally. So to your point, to do those synthetic trials, and in the peds world, you're often going to different sites, right? You're not just going to one place and staying there for your care, and especially if you're a survivor, you're becoming an adult, you're going to adult sites, and how do you track that? And that becomes a huge challenge of, even if you want to share that data, how do you manage it? How do you coordinate it? And I think it's been one of the things that we've been really thinking deeply about, because for us, we've always said, yes, we're sharing the data, we're trying to get out there, and we're starting to have, we onboard new sites, and it's kind of like, what's the toolkit that I can use, or what can I do prospectively? I think a lot of times in the past is like we gathered all this data retrospectively, and we need to just aggregate it and make it into a repository. I think there's a huge opportunity for a lot of people to say, hey, we're generating more data, we're capturing better data, we have better knowledge. How prospectively do we set up so that we are in that world where the data comes in, it's being shared as quickly as possible, with appropriate governance, appropriate security. And I think that's something that we've been really thinking hard about with AWS and our other partners, of how do we create kind of toolkits and packages that people can use to do this, and how does that align with the federal ecosystem, because that's what everyone wants to do. They want to analyze it with the different data efforts that are coming out of NIH and others, and it starts becoming a federated system just kind of by default. And I think even without planning it to be that way, there's these key components that have to happen.
And when you've got the amount of data that we're talking about, and you're trying to get proactive insights into it for the benefit of patients, obviously, the first panel today was about artificial intelligence and machine learning, and there's a huge opportunity. This is the buzzword of the moment. Everyone's really excited about what it can do. What do you think, Annabella, in terms of, where are we going with the AI and ML on top of this federated data platform? Is the future bright?
Oh gosh, that's Here's how I'll answer that question, Roland. I think that AI is evolving so rapidly that my answer could be dead wrong in as soon as like 2 to 3 years. So what I will say, having, I left government in 2016, went and worked in the tech-enabled and AI-enabled RWE space. I think where we really see AI and machine learning excel is in both like repeatable processes and pattern recognition. I think that right now we can see that AI and machine learning and tech generally are good at ingesting these mass quantities of data, right? Work that would exhaust a human. And so I think that through that work, like Allison is saying, we'll start to really derive reliable insights. But I think I can't overstate how complicated that work still is. As someone who in my previous work led the human workforce that is required to clean up that data, to move so much of the unstructured data that exists in healthcare into a structured format for analysis, like that work is not easy. I think that AI will help us do that work much more quickly. So where do I see AI having a role in medicine? I think that we're seeing it right now. Roland and I were actually discussing a New York Times article that described healthcare practices in Hungary using AI to read radiation scans and catching some signals of cancer that the radiologist had missed. I think that is already happening, obviously. And then the second place where I really see it excelling is in that RWE, RWD space to help us derive those reliable insights for patient care.
And again, so AWS has not only got over 130 HIPAA-eligible services that can be built to build some of these clinical platforms, and we're building these services that have got data-specific use cases. So HealthLake is for our FHIR-based servers. That's the medical language. HealthLake Imaging is for DICOM data, so that's for medical imaging and pathology. Omics for genomic and multi-omic data. So all of these different data types are now being catered for with specific services. As I said, there are some services that are being developed for data sharing and data collaboration, and also the specific data services for ANML that were discussed previously around Bedrock and SageMaker Jumpstart, where we are working with partners that are now building foundation models for healthcare. And I think there's an opportunity here for organizations and entities to build foundation models that will really impact these use cases in the future. So I'd like to thank all three of you again for your time here today. I think it's been a fantastic discussion. I think we've been very lucky to have both the administration, federal and non-federal entities represented. My takeaways from this panel, I have 3 takeaways. One is that 2023 is the year of open science for federal government. And I think that's a really important step, because I think all of the agencies will be then lined up to do this mission of open access, open data, and really proactive sharing of real-world evidence. I think there are some fantastic initiatives already underway. So I think the Cancer Moonshot 2 is real, and it's highlighted. We have evidence of the Children's Brain Tuner Network actually making that Cancer Moonshot 2 real. And I'm delighted that the power of the cloud is able to support all of these initiatives by bringing the technology and the ability to federate and share data in a secure environment to everyone. And I think it's about democratization. So I think it's democratizing access to both the data, the tools to assess it, and also the applications. Again, working with partners to make sure that end users have got these applications in their hands and it's available at the point of need for clinicians. So I think bringing it all together is really, really important. So I'd like to thank the panelists again today, and I think they all deserve a big round of applause. And we'll have a QR code shortly on the wall. So if you'd like to find out more about the Cancer Moonshot, the work of the NCI or CHOP, or how your organizations can get involved in any of these projects, we'd be delighted to partner with you. I'm sure the panel will be very welcome to take any questions. And thank you again for your attention. And next up is the keynote by Max Peterson. And I look forward to some announcements involving healthcare during that as well. So thank you very much.